Today we will draw a shape and BM diagram for simply supported beam. First of all, a simply supported beam AP of length L carrying a point load W at its midpoint. So here this is L by 2. We have to calculate a shape and BM diagram for this problem. For simply supported beam, we have to calculate support reaction at A and B point first of all. And remind, don't calculate below this figure because we have to draw a shape and BM diagram. Okay, so at first total upward force equal to total downward force due to equilibrium of the beam. So here RA plus RB, total upward force, and total downward force, this is W. This is first. Second, taking moment at point A and equating the same. Equating the same means total upward moment equal to total downward moment. Taking moment at point A, so at point A there is no moment because here there is no distance. The force, this is RA, but there is no distance. That means RA into 0, this is 0. This is RA into 0 at point A, moment, plus at point B, this is RB, and you will take moment at point A. So here the force, this is RB, and taking moment at point A, so this is the distance L. And this is upward moment equal to downward moment. Downward force, this is W at point C, and taking a moment at point A, so the length is L by 2. So here RB equal to LL cancel, this is W by 2. And putting the value RB in this equation, here RA equal to W minus W by 2, so also W by 2. So here the value RB W by 2 and RA W by 2. So we have to calculate at first the support reaction at A and B point at all the time for simply supported beam. Now we have to calculate shear force. Remind, for simply supported beam, for calculation of shear force, we have to calculate from left to right. From left to right, and the value of shear force at extreme right hand portion, that means at B point, will be 0. We have to prove. So remind, from left to right we have to calculate. So shear force at point A. And again remind, up to for upward force, shear force will be positive. For downward force, shear force will be negative. Always remind. And so shear force at point A, this is upward force, this is W by 2. Now shear force at point C, and the previous load, this is W by 2, and at point C this is W, but this is downward, so this is negative, so minus W. So here this is minus W by 2. Now at point B, but at point B just left, when you don't touch the point B, that means up to point B, the previous value minus W by 2 here, because there is no load from C to B here. When you don't touch the point B. Yeah. Now shear force at point B just right. Yeah. When you touch the point B and show here the value minus W by 2, and when you touch B, the upward force, this is RB, and from upward for upward force this is positive, so plus W by 2. Yeah, so here the value will be 0, and this is proved. So this calculation are correct. Now the diagram, shear force diagram. From every point we have to calculate, draw projection line. Yeah, and this is light line, and here this is medium line, reference line. This is ACB. Yeah. Again remind, for shear force here, for point load, yeah, for point load, yeah, the shear force diagram will be upward or downward, and for BM will be inclined upward. Yeah. Now for point load and for upward, so this will be positive, and here the value W by 2, so this is upward straight line. Yeah, this value here W by 2. Yeah, and up to point C there is no load, so this will be parallel with reference line, and when you touch C, W is acted downward, and here the value minus W by 2. That means here this is 0, and this is also minus W by 2 at the negative portion. Here the value W by 2. Yeah, and look at, when you don't touch the point B, up to B portion there is no load, so this is parallel. When at just left portion, that means here the value minus W by 2, here the value minus W by 2, and when you touch point B, upward reaction RB here, and the value just right, this is 0, and here the value is 0. Yeah, and this is W by 2. Yeah, this is negative and this is positive, and must draw section line. Section line, light line, 45-degree angle, 2 to 3 millimeter gap. Yeah, here, and this is SF diagram, shear force diagram. Yeah, now we have to calculate bending moment diagram. Yeah, bending moment diagram. For bending moment diagram, you can calculate from left to right or right to left, whether you will prefer. Yeah, at point A, look at the figure, at point A, bending moment, the load for load W by 2, if you calculate from left to right. Yeah, so here the load W by 2, but taking moment at point A, so there is no distance, so this is 0. Yeah, bending moment at point B. Yeah, if we calculate this bending moment from right to left, here also the upward force W by 2, this is positive, but we are taking a moment from right to left, so here this is no distance also, so bending moment is 0. Bending moment at point C here. Yeah, the value is at the middle point, so you can calculate from left to right. Yeah, now if we calculate from left to right for load RA, this is W by 2 upward, so this is positive, and this force is acting at point A, and you are taking moment at point C, So the distance here L by 2. Up to point C you have to calculate, and here at point C the point load, this is downward, so this is negative, and there is no distance because this load is acting at point C and you are taking moment at point C. So here this is no distance. So here the value WL by 4. Yeah. Now draw BM diagram. This is reference line ACB. At point A this is 0, at point B this is 0, and at point C. And we know that the BM diagram for simply supported beam always positive because this is due to sagging. And here the value at point C, this is WL by 4. And connect this point here. And we know that for bending moment diagram, this is inclined straight line. Yeah, inclined straight line. Yeah, and this is positive section line. Yeah, and this is BM diagram. And positive sign due to sagging. Yeah, and this is SF and BM diagram for simply supported beam carrying point load at the middle point. Yeah, on the next day we will draw SF and BM diagram for simply supported beam carrying UDL over the whole span. Yeah, thank you.